All right, we are going to start section 1.1b, and the first thing I want to do is define a couple of things. The first one is a finite set. A finite set is a set of numbers that has a definite or finite number of elements. So you can actually figure out what all they are. An infinite set is a set of numbers that has an unlimited, or just as the name implies, infinite number of elements. Now we're going to do set builder notation and also interval notation. We're going to start with interval. And when we're doing interval notation, there are three things that you need to remember. When the endpoints are included, so they're included when they are closed, we use what it's called brackets to show that they're included. When the endpoints are not included, we use parentheses. So those would be open endpoints to show their exclusion. An interval that extends forever in the negative direction goes to negative infinity, and an interval that extends forever in the positive direction goes to positive infinity. So what I would like you to do, just draw a number line up here, and this would be positive infinity. This is negative infinity, just to kind of get you oriented where they are. Okay, here are examples of interval notation with inequalities. So on a number line, if we want to say numbers that are less than 3, this is the inequality. For interval notation, notice we do not want to include the 3, so we use parentheses there. Now if you want to put a little key over here, we can write that a closed endpoint is represented by brackets, and also the inequalities less than or equal to, greater than or equal to. And then we can also say an open endpoint is represented by parentheses or less than and greater than inequalities. So as you look at this inequality, we do not want to include 3. Now look what's happening to the number line. We're going off in this direction, so that's negative infinity. So you always have to have two numbers, and one of them could be infinity. So the smallest on the left, the largest on the right, and then you have to indicate whether or not you want to include those. We do not want to include 3, and infinity can't be enclosed. It keeps on going forever, so you're going to use a parenthesis there. Now if we change this to x is greater than or equal to, because of this equal sign, it means we want to include that negative 2. Now we're going this way, so what's on the left is negative 2. What's on the right is positive infinity. So negative 2 goes on the left, infinity goes on the right. It's not included, so we use a parenthesis, but we do want the negative 2 included. So because of this right here, we have to use a bracket. Now we have numbers that are between 2 and 4. We don't want to include them when we say between, so our inequality would be the numbers are in between 2 and 4, but we're not including them. Now if we put that under there, we would be including them, but we don't want to include them. So smallest number on the left, largest on the right, don't want to include them, either one of them, so that's parentheses. Now the numbers 1 through 3, we do want to include 1 and 3. So if we write it as an inequality, we put the x in the middle here, all the numbers between 1 and 3, and we want it to be less than or equal to 3 because this means closed endpoint means inclusion. So, and we also want to include 3, we want to include 1. So smallest number is 1, goes on the left, largest number is 3. Closed endpoints means we want to include them both, so we use brackets on either side. Okay, a couple of examples here. Again, we want to use two numbers, or we'll use the infinity. This one isn't landing on a number, it's going off to negative infinity, so that goes on the left, and the negative 1 goes on the right. This is a closed endpoint, so we do want to include that, and negative infinity is not enclosed, or included, so we're just going to put a parenthesis on that side. Now when you see the word or, it means you're going to have two different intervals, and we'll put or in the middle. So first we're just going to concentrate on, this one right here, and x is less than negative 2, or positive 2, sorry. If I put that in a number line, here's 0, here's 2, and we would put a closed circle, at 2. This is pointing less than, so we'll go like this, and that means that goes off to negative infinity. So we'll put a negative infinity here. We'll put a positive 2 here. We want to include 2, and infinity always has a parenthesis. Now we need to work with the other one here, and if you want to put it on a number line, sometimes that helps. So if it's greater than 3, now some people say, well, that's a less than sign. That's correct, but we're reading it from x this way. So x is greater than 3. So we're going to put an open circle here. We'll put a closed circle here because of this right here. And when I say circle, I'm talking about the end points. And we want everything in between. So we want to go in between here, which means the 3 would be on the left, the 11 would be on the right. Closed endpoint means a bracket. Open endpoint means a parenthesis. So just a reminder here that the word or is used when 2 or more intervals are on a number line. All right, let's finish it up on the other side here. Now, set builder notation seems to always cause students difficulty and a little bit of anxiety. So I have here set builder notation kind of described. You want to make sure that you have, this is going to be listed for every single problem that you do that has set builder notation. So basically, if I gave you 3 problems, you would do set of all numbers x such that, set of all numbers x such that, set of all numbers x such that. Okay, and what this means is we're using x to represent the numbers that we're talking about. You can use any variable you want, but x is the most common. That's what we're going to use. So again, this, let me just highlight that here, grab a highlighter. This is going to be the same every single time. All right, and then we have to say what our range is. What numbers are we looking at? So basically, if I gave you a number line, this would be 8, this would be 15. We're going to put an open circle here, or endpoint. We're going to put a closed endpoint here, and we want to talk about everything in between. Okay, now when I write this, this includes 8.5, 8.7, 8.983, and so there's an infinite number of numbers on here. So when you are on the number lines, we're including all the decimals, all the fractions, all the irrational numbers, any square roots that are in there. So this is added when we don't want to include all of the decimals and fractions, because remember from yesterday that natural numbers are counting numbers, so they're 1, 2, 3, comma, dot, dot, dot. So basically, this number line would not match up with this. If I cover this up, that number line would be correct. But because I say that we're looking at the natural numbers, my number line now would not include 8 because there would be an open endpoint there. But it would be, here would be 8, this would be 9, 10, 11, 12, and we'd keep going on. These would all just be dots. There would be nothing connecting them in between. We would just land on these points. Okay, we're going to write this in set builder notation. So notice this is solid here. So that means we're including 1.5, we're including 2.8, and everything in between. So set builder notation means I start out with the set of all numbers x such that. Now I have to give what numbers I'm in between. So basically you can plot the x right down here. And we're in between 0 and 4. So we need this part, oops, let me go down here, this part of the set builder notation. So we're going to come down here, and we're going to say we were in between 0 and 4, open endpoint, so x is in between these, open endpoint would be a less than sign, closed endpoint, that means it's going to be greater than or equal to 0. So this is what gets put in here. We are less than 4, but we're greater than or equal to 0. Now, I'm not just talking about just 1, 2, 3. So whenever you're talking about all of the numbers on the number lines, the fractions, the decimals, and everything, you can just close this right up. Now, some people might write it like this, the set of all numbers x such that x is less than 4, greater than or equal to 0, and x is an element of the real number system because we're talking about every single number in between. So that's fine. I'll accept either one of those. You really don't need this. But again, this one up here, by putting this on, it takes out all the numbers on the number line and makes it just these individual numbers here. Okay. So I skipped over the part in words here. This is actually if we would want all the numbers that are less than 4 and greater than or equal to 0, or say it the other way around, all the numbers that are greater than or equal to 0 and less than 4. All right, last one. We're going to translate between notations. So we have an interval notation here. We want to put that in set builder notation. So let's just go back to a number line again. Sometimes it's easier to see when you have a number line. So I'm going to put an open circle here, or an open endpoint, and a closed endpoint here. We want everything that's in between, all the decimals, all the fractions. So set builder notation, always start out with the set of all numbers x such that. Now we have to put what numbers we're talking about. Well, we want all the numbers that are in between 15 and 3. This is closed endpoint, so we want less than or equal to. This is an open endpoint, so we want x is greater than 3. We're going to take this, put it right in here. And because we want the decimals and fractions, now we're done. Going from set builder notation to interval notation. I need the smallest number and the largest number. So negative 13 and 5. That includes negative 13.